All right, so let's take a look at our lesson for today. We're going to be looking at a topic called advanced limits. These are really complex limits. I know you're excited about that, right? Ah, more exciting limits. Okay, so let's look at the two different types, really, I guess technically three different types that we might encounter. So if we have a composite limit, this is the formula. You probably, I don't know, maybe you remember it. It's on the formula chart. This formula actually only works if f is continuous at the location that this limit exists. But what if f is not continuous at that location? Then what? Okay, then it's the technique that I'm going to show you today. Another thing that can happen, when you have two functions that you are multiplying or adding or subtracting, these little things, what if f and g are not continuous at a? What then? Then what? These formulas are true if f and g are continuous there, but what if they're not? And that's what we're going to investigate today as well. So for these kind of complex limits, we have to look at either one-sided, well, we have to look at the one-sided. So we're looking at one-sided limits. And more specifically, we have to look at the inside limit, and we have to pay attention to the limit, whether the y value is being approached from above or below. That is significant. Normally, we don't care. Normally, we don't even look at that. But this really matters in these kinds of limits, because what it does is it affects the location of the second limit. And as we do examples, I think you will understand what I'm saying. So what I've done is I've just written out and I put words by it, I've physically written out an example of what I'm talking about. So on this question, we're asked to find the limit as x goes to 2 of f of x. So what do? We take the inside limit first. This is the inside limit. And we're going to look at the graph. So we're going to look, so we've got x is 2, we're going to 2, we're headed this way. We're headed to 2 from left and right. And we get to, this is where we're going. We're headed to a y value of 1. Now, are we headed to the y value of 1 from above that y value or below? This is significant. We're headed to the y value below this one, y value of 1 from above. See how I put these little red arrows there? See how we're headed from the right side, we're coming from above, from the left side, we're coming from above, from the above. And for that, above we use plus to basically signify we're coming from above. So as we look at this work, we can see that we are headed to 1 from above. This is the inside limit. We're approaching 1 from above on the left and right as seen in the graph. That's why I've got a plus here. I'm going to pause here for a second. Does everybody understand why I have a plus there? Because we're approaching the value of 1 from above. Okay. So then what I do is I take this value right here, and it becomes where the limit is going, and we're going to call it u instead of x. I mean, if you wrote an x down there, it's fine, but I'm just saying we typically would write a u. That's where this number comes from, is from our answer to the inside limit. So then what do? We look at the limit as u goes to 1 from the right. So here's 1 right here. We're coming from the right. Notice how coming from above is transitioning to coming from the right. That's a nuance. Those are technically different, right? Coming from above is equated to or related to coming from the right. As I head to an x value of 1 from the right, where is my y value headed? It's headed to 2. And so my answer is 2. Now I'm just going to ask you this question. First, let me let that sink in. Are we okay with that? So let's look at a different scenario. What if I was heading to this y value of 1 from underneath? What if I was coming from underneath? Then this would be 1 from underneath, right? And this would be 1 from underneath. And my answer would have been coming from the left, or -2. See how completely different my answer would be depending upon how we're approaching the first limit. With me? Okay. I know this is very abstract, but that's how this works. So, questions before we have 6 examples to work through. Hopefully giving you a bit of a bunch of different kinds, so hopefully you can understand how this works.
So how did you choose which one that you're gonna, like, you have the one coming from the positive and one coming from the, or one from the above and one from below? How do you know, like, which one you're looking at? Like you said, the one's going towards 2.
Are you talking about the second limit?
Yes.
How do we know? We know by this sign right here. If I was coming from above, that means I need to approach the second limit from the right.
Okay.
If I was coming from below, that means that I would need to approach the second limit from the left.
Okay.
That's what tells me what to do. Okay? Anything else before we get to our examples?
Will these always have a graph?
They will always have a graph. Yes. They will always, you will always do this with a graph. Okay, anything else? All right, so let's look at our examples. And they're weird graphs, right? These are just weird pieced together graphs. That's what they're going to look like. They're going to look weird. All right, so these are our graphs. Our first, this one is F, and I'm just going to highlight, I don't know, we'll just make it obvious. This is F, and this one is G. Okay, just to make sure we're reading off, because as you can see, this is very complex. We need to be sure to read off the correct graph. All right, here we go. So the first one, we're doing, we'll do the inside. So we're going to do this inside one first. We're going to do the G one first, right? That's going to match that graph over there. So we're going to come from both sides. So the limit as x goes to 2 from the left of g of x, it's going to equal something. And the limit, I'm going to write them both out as x goes to 2 from the right. This is going to be how we start every single composite function like this. We're going to do from the left and from the right on the inside function, period. Okay? Every single one. This is how we start. From the left and the right of the inside function. So let's look at G. Here's G over here. And we're focusing on 2. So the first one, we're coming to 2 from the left. So I'm headed this way. And I'm approaching a y value of 1. Is the graph approaching from above or from below? Above. Since it's approaching from above, I'm going to write this y value down, which is a 1, and I'm going to say from above, the plus. All right. Now let's work on the other one. We're going to approach an x value of 2 from the right. We're coming this way. Okay, we're approaching from the right. And of course, that's the y value, but again, I have to pay attention. I'm coming from the right. And is the curve coming from above or from below? It's from above. So this is going to be to the right also, to above, plus. Okay, so that's our first step. So now I'm going to, then it's okay. They don't have to be the same. It's okay. Okay, and some of the examples will not be the same, and you'll be able to see that as well. All right, so now what I'm going to do is I'm going to write my outside limit. So the limit, and we're going to change the variable to u. U is going to 1 from the right. And again, why am I doing that? Because this became that. 1 from the right of g, f is the outside one, f of x. And the limit as u goes to 1, and this, strangely, it's not that normal that they're the same, but this is, 1 from the right. So this is also 1 from the right of f of x. And of course, these are identical limits. They're going to turn out the same. It just isn't always like this. I'm just showing you a bunch of different kinds of ways it can happen. So let's look at our graph of f, and we're going to look at 1 from the right. Here's our graph of f. Here's 1. We're coming from the right, and we're approaching the x value of 1. What y value are we approaching as we're coming to 1 from the right? 1. So this is 1, and these are identical, so that's 1. So my answer is 1. Now, these two answers have to match to get the full answer. If they don't match, what do you think our answer is? D and E does not exist. If they don't match, these last ones, not the inside ones, those don't have to match. I'm talking about the results. The end results of both sides have to be the same to have an answer that's an actual answer instead of D and E. Okay, how are we on our first one? Okay, let's look at our second one. So this one is different. I've got f of x plus g of x minus 5. Okay, this is strange notation. I want you to think back to pre-cal. What does this mean with transformations? What does that mean? It means is shifting right or left. Which way is this one shifting? It's right, because it's opposite, right? Because it's root, right? That's root, opposite. Okay, this is shifting to the right 5, but we aren't going to have to worry about physically taking the graph and moving it in our brain. We have an algebraic way to do it. Okay, so let's work through that. We still need to come from the left and the right. So let's write these out. So we're going to look at the limit as x goes to 1 from the left. And I write the whole thing out, f of x plus g of x minus 5. And we're going to look at the limit as x goes to 1 from the right of f of x plus g of x minus 5. Okay. Everybody okay? We're going from the left and the right. Now, when we have a regular old function like just f of x, that's pretty straightforward. It's straightforward. We're going to look at the graph of f. So where is it? It's right there. We're going to look at the graph of f, and I want to see what is happening as I approach 1 from the left. I'm coming this way. I'm approaching 1 from the left. What y value am I headed towards when I approach 1 from the left? -2. So that's -2 plus. Now, when I have a transformed strange thing like that, what I do is I put the 1 in here. 1 minus 5 is -4. And I write down g of -4. And I'm going to basically copy this down from the left. We're going to go from the left. It's going to look like that. Okay. Again, why is this negative right here? Because this is. We're coming from the same side as our original limit is coming from. Same side. Okay? All right, so now let's do that. Let's look at g, that's this one, and we're looking at -4, that's right here. And I want to approach -4 from the left. I'm coming from this side. What y value am I approaching as I'm coming from the left? Remember, one-sided limits, we have to attach ourselves to the curve, and then we move along the curve, right? 1. I'm coming to 1. So this is -2 plus 1, which is -1. And that's the left-sided limit. All right, let's look at the right-sided limit. Okay, so I'm headed to F. I'm headed on F. That's this graph over here. I'm headed to 1 from the right on F. I attach myself to the curve. I'm headed to 1 from the right, and I get to a y value of 1. Okay? Plus, again, we're going to put a 1 in there inside of this transformation. 1 minus 5 is a -4, and I'm going to approach -4 from the right. Why am I approaching from the right? Because that's the limit we're working on, the one from the right. Okay? So here we go. So that's 1 plus. Now let's look at our G graph. We're going to -4, and we're coming from the right. So I attach myself to the curve, and I'm headed to -4 from the right, and my y value is -2. So, which 1 plus -2 is a -1. These are the same, so that is my answer. Okay? We good? Let's look at number 3. These are very complex. If it takes you all 6 to figure it out, it's okay. They're very complex. It's fine. Okay, so let's look at number 3.
Why don't we do a second limit on number 2? Like, why don't we only do like one limit for each side? Like on one we used the answer from the first limit, and then we put that in as like the.
So because on number 1, it was a composite function. It was one inside of the other. And number 2, it's two functions being added together. Those are, we have to do them differently. Okay? So the composite functions, we do all those the same way. The adding, multiplying ones, we do all those the same way. Those are basically 2 types. Okay, so number 3 is the composite. We're going to have to do it like we did number 1, where we've got the inside function, which is f. Okay, so I'm going to set this up. So we've got the limit as x goes to 1 from the left of f of x. And the limit as x goes to 1 from the right of f of x. Now these are the ones where you have to pay attention to if it's approaching from above or below. That's this kind. The composite functions, we have to pay attention to that. All right, so let's look at our graph F. That's this one right here. We're looking at 1. On the first limit, we're headed to 1 from the left. Okay, remember we attach ourselves to the curve. Coming from the left, we're here. We're headed to a y value of -2, but are we approaching it from under it or over it? Under it, under it. So that means this is going to be -2 from the left. Okay? Now let's look at the other. We're still on the graph of F. We're approaching 1 from the right. So I attach myself to the curve. I'm approaching 1 from the right. And I'm headed to a y value of 1. But am I headed to that y value from above it or below it? From above it. So this is going to be 1 from above or to the right. Remember, we're doing above translates to right when we move it into the second limit. We okay? Okay, so let's translate to the second limit. All right, so now we've got the limit as u goes to -2 from the left of g of x. We've got the limit as g of u. I have to match them. It's a U. All right, so now we're going to U goes to, what is this, 1 from the right of G of U. Okay, so let's look at our graph of G. It's over here. Let's see, so we're going to -2 from the left. We attach ourselves to the curve, we head to -2 from the left, and we get 2. Okay? We're looking at the graph of G, and we're headed to 1, x value of 1 from the right. I attach myself to the curve. I'm going to 1 from the right, and I get 2. Since these two match, what is my answer? It's 2. Okay? Let's look at number 4. That's another composite. Hopefully we're getting the hang of composites. We're feeling okay? Those are all done the same way. So let me write it out. So we've got, let's see, we've got the limit as x goes to 3 from the left of the inside one. And the limit as x goes to 3 from the right of the inside one. Okay, so we're looking at f. We're coming at 3 from the left. So again, I attach myself to the curve. I'm headed to 3 from the left. Where am I going? I'm going to infinity. So this, I'm going to not say an equal. Remember, we're going to arrow infinity. Now let's go to 3 from the right. I attach myself to the curve. I head to 3, and I'm headed to infinity. Yes, if that was a normal number. If it's infinity, infinity is its own little beast. It's just infinity. But if that were like 2, we would have to say it's coming from underneath, right? 2 like from the left, from a negative. But this is infinity, it's just infinity. Or if this were, certainly it could have been negative infinity, right? That still would just be negative infinity. We wouldn't care where it was coming from. Does that make sense? Okay. So let's now do our secondary limit, the outside limit. So we've got the limit as u goes to infinity of g of x, or g of u, excuse me, and the limit as u goes to infinity. And these are the exact same limits, right? They're the exact same of g of u. It turns out that way sometimes. So let's look at g, and I want to go to infinity. So I attach myself to the curve, and I just keep going to infinity forever. What's my y value that I'm approaching? -2. And those are identical, so it's -2, -2, so my answer is -2. Okay? All right, let's look at number 5. This is a multiplying one. All right, so here we go. So the limit as x goes to 4. On multiplying ones, do we need to worry about if we're approaching from the right or the left? Well, let me remind you, see how on the adding ones, it was this part that we were concerned with, right? And this part didn't have anything to do with the graph. Well, the -4 did, but remember this came from here. It's different. This comes from here. Okay, so keep that in mind. All right, so we're going to 4 from the left of f of x minus 3 times g of x. And then we're going to 4 from the right of f of x minus 3 times g of x. Okay. So that's going to be. So when we have the weird transformed ones, what do? We just put the number in and we say we're going to head from the left. You with me? put the number in. So I put the 4 in. 4 minus 3 is 1. So I need f of 1, but I need to approach it from the left. Now, 4 from the left of g, that's just looking at the graph. That's straightforward. So let's go to the graph of g, which is this one over here. And we're going to, let's see, g is 4 from the left. That's a positive 4. 4 from the left, that's just 0. So we're multiplying by 0. Okay? Now, please don't assume that's 0, because what if this is infinity? Is infinity times 0, 0? No, it is not. No, it is not. So let's look at 1. So we're going to the f graph, and we're going to 1. Here's 1. Coming from the left. So we attach ourselves, and we get to a negative 2. So this is negative 2 times 0, which is 0. By the way, I expect you to show this work on a test. If you just write an answer, that's not going to be okay. Okay, you need to show all of the work that I'm showing right now. Okay, here we go. Let's do our second one. So we're doing f of, I put a 4 in there. 4 minus 3 is 1, and we're coming from the right. Why are we coming from the right? Because this limit is from the right. That's why. Times, now I need to look at g. The graph of g headed to 4 from the right. So 1, 2, 3, 4. Coming from the right is 0. So let's look at f going to 1 from the right would be 1. And 1 times 0 is 0. So what's our limit? It's 0. Last one. So infinity times 0 is an indeterminate form, and we would have to do L'Hopital level 2. Exciting. We would have to rewrite the limit. So we shouldn't have one like this with graphs. That would be with equations. We shouldn't, I know you're happy about that. We shouldn't have one like that with graphs. All right, so let's look at this last one. It's composite, so what do we do with the composite ones? We do the limit of the inside, right, from the left and right. So here we go. It's the limit as x goes to negative 3 from the left of g of x. And the limit as x goes to negative 3 from the right of g of x. Okay, that's what we're going to be looking at. So let's look at our graph of g and see what's going on at negative 3. Here's g, there's negative 3. Okay. Now here's where we have to pay attention to how we're approaching. I'm going to negative 3 from the left. I attach myself, I come here. I approach 1, but am I approaching 1 from underneath or above? Underneath, so we're coming from underneath, which would be like the left. Let's look at negative 3 from the right. Okay, so we're looking at g, we're attached to the curve, we're going to negative 3. I'm also going to 1. But how am I approaching this one? From above, so that's going to be a plus, right? So this one is going to be 1 from above. All right, now let's do our secondary limits, or the outside ones. So the limit as u goes to 1 from the left. Okay, where did I get that? I got it from here, right? That's how that works. Of f of u, and the limit as u goes to 1 from the right of f of u. And again, I got that from here. Okay? So let's look at our graph of f around 1. Let's see what's going on. That's this one over here. Okay, so here, let's get rid of that. We're going to 1, which is here. So the top one wants us to approach 1 from the left. So I'm coming from the left, I attach myself, and I end up here at -2. Okay, the bottom one wants me to approach 1 from the right. So I attach, I come from the right, and I end at 1. What's going on here? It does not exist. Since these don't match this limit, and don't say equal, please, just arrow D, N, E. And there we go.